Good morning. Today we're going to be looking at AIM 1.3. So that is Unit 1. That's what the 1 is. And 3 is going to stand for the third lesson. So how can we use environmental indicators to assess the state of the environment? So today we're going to be discussing the environmental indicators, what they are, and how do we use them to assess the state of the environment. The objective is to identify the key environmental indicators and their trends over time, and also to convert from hectares to acres. So we are going to learn a little bit of math today. There is a little math in AP Environmental, but this is simple. It's just converting from one unit to the next, and I'm going to walk you through those steps. So we're going to start first with what ecosystem services are. So those are basically life-supporting resources such as clean water, timber, fisheries, crops, things that the environment is going to have, right? So they're produced. They're life-supporting resources that are produced by the environment. All right, now to environmental indicators. So what are environmental indicators? Basically, that describes the current state of the environmental system. So is the environment currently stressed, or is the environment being productive and considered, healthy, right? So we're going to walk through some major environmental indicators that scientists can use to kind of take the temperature of the environment, right? So if we're sick, what do? We usually use a thermometer. We take our temperature. If we have a fever, we might know that our body's stressed, something's going on. We might be fighting an infection or a virus. Whereas with the environment, there is no thermometer for the environment, right? You can't just take the temperature of the environment. Well, you can, but not in that way to know if there's a fever, and see what might be causing the stress in the environment. All right, so the 5 global scale environmental indicators we're going to focus on today are 1, biological diversity, 2, food production, 3, average global surface temperature and carbon dioxide concentrations in the atmosphere, 4, human population, and 5, resource depletion. So basically, these 5 global scale environmental indicators are going to give us an idea of how the environment is doing on a global scale by using these different indicators, right? So we'll talk more about that as we go through each one. So when we talk about biodiversity, that's the diversity of life forms in an environment. So how diverse is it? So it's going to exist on 3 scales. So we're going to break down this diversity on 3 scales: on the ecosystem level, on the species level, and also the genetic level. So one thing to keep in mind is that biodiversity is extremely important for an environment to thrive, right? So you need high biodiversity on all 3 of these levels in order for you to have a thriving ecosystem. Let's now break down to genetic diversity. So a measure of the genetic variation among individuals in a population. So you want to have high genetic diversity. So let me give you an example why. So you want good genetic variation within your ecosystem, let's just say. Why? Because let's say a virus comes in and it attacks a species of plants, let's just say. If there is a low genetic diversity and all the plants are the same, that virus may wipe out that whole population, right? Like, let's take a look at these bananas here. Let's say we're talking about banana trees, right? Let's say a virus comes in and there's very low genetic diversity and it knocks out that whole population, right? So you want high genetic diversity because let's say you have a big genetic variation amongst your banana plants, right? That means that those banana plants would more likely there might be some individuals that may be able to withstand and be immune to that virus, so your whole population will be wiped out, right? So having high genetic diversity is going to allow for a population of species to be able to bounce back if there's, say, a virus or a natural disaster, something that could potentially wipe out that species. So you want high genetic diversity to protect species. So we're talking about species. What exactly is a species? It's a group of organisms that have distinct morphology, so their body form and structure, their behavior, biochemical properties. So specific things, like you can have different species of butterflies, different species of dogs, different species of plants, right? There are estimated 5 to 100 million species on Earth. Approximately only 2 million have been identified. Now, why is there such a big gap in a range? Because scientists don't know the exact number. It's kind of impossible to know the exact number because every day you might have a fluctuation in the different amounts of species. Every year you're going to get new species, and every year you're going to get species that go extinct. There might be species that go extinct as we speak that have never been discovered. So we can't pinpoint the exact amount of species because that's going to fluctuate. All right, now the next one, so we talked about genetic diversity. The next one is species diversity, the number of species in a region or a particular type of habitat. So you want to have more diversity within an environment, right? So you have a more complex food web. That's very beneficial, right? So, for example, let's say you have this less diverse ecosystem, right? So you have less species within an environment. So there's not that many different species. And let's say one species that a group of organisms rely on as their only source of food gets wiped out. What's going to happen to the food web? It's going to be disrupted, right? Excuse me for a second. So it's going to be disrupted. So in order to try to prevent a total collapse of your ecosystem, it's good to have many different species. The more species within an ecosystem, that's an indication that you're going to have a thriving ecosystem, right? So you want as many different species, as much genetic diversity as possible. Now, speciation, speaking of species, there's about 1 to 3 new species per year, right? So through evolution, you're going to have approximately 1 to 3 new species per year. Now, bringing back what I said before when we talked about why scientists can't pinpoint is because of speciation, the amount of species is because of speciation, also because of the background extinction rate. So the rate at which species become extinct over a long term. So it should be about 1 to 2 species per year. And in fact, it's about 1,000 species per year that go extinct. Now, why is this the case? Yes, there's natural reasons, but mainly because of humans, right? Throughout this whole course, we're going to talk about different human practices that are going to harm the environment and may lead to species to go extinct. Right now, background extinction rate. So the rate at which species become extinct over a long term. So it should be about 1 to 2 species per year. And in fact, it's about 1,000 species per year that go extinct. Now, why is this the case? Yes, there's natural reasons, but mainly because of humans, right? Throughout this whole course, we're going to talk about different human practices that are going to harm the environment and may lead to species to go extinct. Right now, the background extinction rate is about 500 times what it should be, right? So naturally, throughout geologic time, species have gone extinct for environmental reasons. But since humans have been put on this planet, we have increased this background extinction rate to about 500 times of what it should be. All right, so what factors other than anthropogenic human activities cause species to go extinct? So you may think of some others that are not listed here, but here's some natural things. Climate fluctuations. Yes, right now humans may be influencing the climate, but climate does change naturally, and throughout geologic time, we've had ice ages, periods of extreme warmth, and through these different cycles of climatic change, we have seen species go extinct because they're not able to survive in the new climate conditions. Natural disasters, right? Hurricanes, tornadoes, well, maybe not a tornado. Maybe a tornado is not going to cause a species to go extinct, but possible natural disasters like flooding from hurricanes, maybe, there might be, extreme ice event with lots of snow. So a natural disaster may cause a species to go extinct. Meteorites, dinosaurs, 65 million years ago. If you look in the Yucatan Peninsula, there's evidence that a meteorite made contact with the Earth's surface, which led to the extinction of the dinosaurs when all that ash flew up into the atmosphere, blocked out the sun, and caused the dinosaurs to go extinct. Also, competition among species. The stronger species that may outcompete the weaker species and cause them to go extinct because of the competition for resources. So these are some examples of human non-anthropogenic activities. So one thing before we move on to the next topic is the word anthropogenic. Anytime you see that term anthropogenic, that refers to human activities. Anthropogenic is human activities. Okay, ecosystem diversity, the third one. Measure of the diversity of ecosystems or habitats that exist in a given region. So the greater number of healthy and productive ecosystems means a healthier environment overall, right? So in a region, the more healthy ecosystems you have, it's an indication that the overall environment is in good shape, right? So this is one indicator: the diversity of ecosystems, the diversity of species, the diversity of the genetic material. So the more diverse all of these things are, the better the environment is. All right, now we're gonna get into a little bit of math right now. Why? Because some measures of biodiversity are given in land area. So this is how this relates, right? So we're gonna use the term hectares, which is a unit of area used primarily in the measurement of land. So that's 100 meters by 100 meters. What is a hectare equivalent to? About 1.3 soccer fields. So now let's get to the math. So I'm going to walk you through this. Some of you might think this is very easy. Some of you might struggle with this a little bit, but I'm going to walk you through this. So let's start by reading the problem. There are 2.47 acres in 1 hectare. Okay, so right away, if you have a highlighter or something, I would highlight this. If you're reading a math problem, my first suggestion is to highlight, underline, mark notes on the side of the information they give us. So right now we're figuring out what information do they give us. So one thing I would note is that there are 0.47 hectares in 1 acre. All right, so I would highlight that, all right? Next, the conversion from hectares is relatively easy to do without a calculator. Rounding to two significant figures gives us 2.5 hectares in 1 acre. So I'm going to highlight this in a different color. We'll go with green. So I would use this now because they're saying that we could round it, so that gives us 2.5 acres in 1 hectare, so we can use the 2.5 when finding our answer. Now to the actual problem. If a nature preserve is 100 hectares, what is the size in acres? So they're giving us another piece of information that I would highlight. So the nature preserve is 100 hectares. So highlight that. Now, what do they want us to find? The size in acres. So I'll highlight that in purple. Okay? So we're going from, they're giving us hectares, and we're going to acres. So how would we set that up? So let's take a look down here. So we're taking this information, hectares, so we'll start out. I would always start with the information they give you, right? How can we start with information we don't have? We don't have acres, right? So we need to start with the information they give us. So they give us 100 hectares. So you're going to write 100 hectares here, like I have right here set up. Now we want to go from hectares to acres, so let's go back into the problem and see what information they gave us to lead us into getting acres. So if you look back into the problem, we highlighted that 2.5 acres in 1 hectare. All right, so, sorry, let's go back here. So if we have 100 hectares here, we want to cancel out units. So when you set this up, this is called dimensional analysis. What you want on the bottom is hectares because you can cancel them out. All right, so what do we want to put here on the bottom? Our answer is in acres, right? What is the size in acres? So we don't want to cancel out acres. So on the bottom, you put 1 hectare, like we see here, and then on top you do 2.5 acres, okay? Now we are going to multiply 100 times 2.5, and you should get 250 acres. Okay, I'm actually going to do that on the board again for you so you could understand that. So I'll place this over here so we could see. All right, so let me try this marker over here. So we're starting with the information they give you. They give us of course this doesn't work, right? So we're gonna start with 100, okay, 100 hectares. All right, now we want to get rid of hectares because our answer is in acres. So what you're going to do is go back, like I said, into the problem. You're going to see that in 1 hectare you have 2.5 acres. So you're going to multiply that. 1 hectare on the bottom, you're going to do 2.5 acres. All right, and you are going to get rid of hectares, and that should give you 250 acres. Oops. All right. So basically, when you're doing problems like this, which you're going to do in your exit ticket, you have to highlight the information they give you. You have to ask yourself, what do they want us to find? once you broke down the information, you can organize it on the side and then put it together like this. So remember, anything you want to cancel out needs to go in the bottom. You don't want to cancel out acres because acres is your answer. If you have any further questions, you could always visit the extra help hour, and I'd be happy to walk you through these steps again. All right, moving on to the next problem. A particular forest is 10,000 acres. Determine its size in hectares. So this is the opposite, right? So I'm going to walk you through this same type of problem. So highlighting, first step, we're going to highlight what they give us. So a forest is 10,000 acres. So instead of us getting what hectares, now we're going from acres to hectares. So we're going to highlight, they're giving us 10,000 acres. What they want us to find, they also gave us 2.5 acres in a hectare. Highlight that. Now, what do they want us to find? That's this last question you should ask yourself after you figure out what they give us, is to determine its size in hectares. So like I said, we're going in this problem from acres to hectares. Okay, there are 2.5 acres in a hectare. Now let's set this up down here. You have now, what information do they give us? 10,000 acres. So you're going to start right here with 10,000 acres. Now, this is different. They want us to go from acres to hectares. So ask yourself, what do I want to cancel out? If my answer is in hectares, I want to cancel out acres. So the other piece of information in order to do that is right here. 2.5 acres in a hectare. So you're going to put acres at the bottom, and you're going to multiply across and divide by 2.5, and you get 4,000 hectares. So you're basically doing 10,000 times 1, 10,000 divided by 2.5, and you get 4,000 hectares. Again, if you're struggling with this, you can always attend the extra help and ask me a question. If you know another... Sorry guys, that was a bell. If you know another method that works better for you and you can still get the same answer, feel free to use that. I'm showing you this method of dimensional analysis because I find it beneficial when you're trying to cancel out units so you don't mess up. All right, so the reason again why we did this is because we're talking about areas in land when we're talking about diversity of species and that. Now, another good indication is food production, right? If you're able to produce food in large quantities, then the environment is probably doing good, right? If your food production takes a hit, that means that there might be something up with the environment. Maybe something is wrong that is preventing, like for example, let's say there's a drought, right? There's a drought that's going to affect their food production. So if we are able to have global scale food production and it's thriving, that tells us it's a good indication of the environment. If there's a problem like a shortage of food, then that tells us there might be something wrong with the environment, whether that be a drought, whether that be climate change, something that might disrupt the natural growth of food. All right. So what are the 3 most consumed grains in the world? That's going to be wheat, corn, and rice. And throughout the year, we're going to talk about other uses for corn that they might use as a fuel source, such as for cars. All right. Another indication is greenhouse gases, right? So greenhouse gases, the greenhouse effect, we'll elaborate on that more when we talk about climate later in the year. But greenhouse gases basically trap heat. In a nutshell, we'll give a quick overview, trap heat within the Earth's atmosphere, and that causes the overall temperature of the Earth to change and increase. Now, these are the greenhouse gases. We have carbon dioxide, methane, water vapor, which a lot of you might not be familiar with that as a greenhouse gas, but water vapor, which is the gaseous form of water, is actually a greenhouse gas that traps heat. Nitrous oxide and fluorinated gases. So these are some examples of greenhouse gases. Now, carbon dioxide is a big indicator for, and there's the bell again. So greenhouse gases, carbon dioxide specifically, is a good indicator on the state of the environment. If you have high levels of CO2 in the atmosphere, that's going to indicate that we're going to have periods of warmth, where if you have low amounts of carbon dioxide, that indicates that the temperatures are going to be cooler. Later on, like I said, when we get to the climate unit, there are different warming potentials for these different greenhouse gases. So as a consequence, if you have more CO2 in the atmosphere, that's going to lead to warmer temperatures, more evaporation, and more water vapor is going to get into the atmosphere because of the increased evaporation. So just long story short, these greenhouse gases, the amount of them in the atmosphere is going to indicate the state of the environment. What is the current state of the environment? All right. Are we having periods of warmth, or are we going to have a period of cooler period if we have less of these greenhouse gases in the environment? All right. We'll elaborate on this later on. This is just, we're discussing this purely as an environmental indicator that scientists use greenhouse gases as an indication of kind of like taking the quick temperature of the environment to see what is the state of the environment. Is it under stress? Is it thriving? These are one of the indicators, just as the diversity of species, the genetic material, also talking about food production. These are all indicators of how the environment is doing. Now, like I mentioned before, this term anthropogenic, it's going to come up. I already mentioned this, derived from human activities, combustion of fossil fuels, for example, net loss of habitats and forests. So keep that term in mind, anthropogenic human activities. Human population. Okay, right now our human population is about 7.8 billion and growing. That is a huge number, right? They estimate that just in a few years we're going to reach 9 billion people on this planet. Within this century, we're going to reach 9 billion. Now, scientists estimate how many people this earth can actually hold, right? So there's limited resources, and if you take a look here on the slide, it places more demands on natural resources and systems. So more people equals more demand on our natural resources, right? I don't know if we could have 9 billion people on this planet and we all have an iPhone, right? And we all have a car. I don't know if scientists aren't sure what the cutoff is. There's debates about that, of how much we can support on this planet, right? We only have a certain amount of resources. So as our human population is growing every single day, we're going to see how does that indicate the stress on the environment, right? What is the population's effect on the state of the environment? So by scientists looking at human population, that's a good environmental indicator on the state of the environment. All right, resource depletion, right? As human population increases, some of the stressors on the environment is resources are going to go and become depleted, right? More stress on the environment, there's more people, more demands. We're going to see resources being depleted, and that's going to be a bad indication of the state of the environment. Now, development, improving the human well-being through economic advancement, right? So this concept of development, humans are constantly developing new technologies to try to improve humans, right? Their quality of life all across the world. So we'll be looking at this development throughout this course. Sustainability. The next part of this course, later on, we're going to talk about sustainability, right? So we're going to see how can we use resources in a responsible manner. Not saying we can't use any resources, because that's pretty impossible. How would we live as humans without using resources? But be responsible about it and don't deprive future generations of those resources. Okay, so we'll be getting into sustainability later on. Sustainable development basically takes this idea of when you're trying to improve human quality of life, right? Through different advancements. Well, why not do these advancements more responsibly, right? More sustainably? How can we preserve resources for future generations, but still improve the quality of life for humans? And just another term, this is in your textbook, which not sure when you guys are going to get one, if you're going to get one, but I'm going through the content with you no matter what. So one of the terms that you think about is biophilia, which is the love of life. So loving life and the environment. And the ecological footprint, a measure of how much an individual consumes expressed in area of land. So one individual person, how much energy, how much food are they going to use, what's their carbon footprint, right? All these different things, how much an individual is going to consume, just one person. All right, so now you guys are going to do the exit ticket, which is how many hectares of land is a 500-acre park. Okay, so make sure you show your work in your exit ticket. I know this is a long module, but also go back to the AIM, try to answer it, try to use this lesson to provide some examples. So for example, how do we use these environmental indicators to assess the state of the environment, right? So think back to genetic diversity, all the diversities, right? Ecosystem diversity, think back to food production that we discussed, think back to the greenhouse gases, all food production, I think I mentioned that. All these different environmental indicators, how do we use them to assess the state of the environment? All right. And that concludes lesson 1.3.